Today we're going to be talking about scientific notation. So our learning target, how can I represent and manipulate numbers in scientific notation? Vocabulary, the parts of scientific notation. We covered this in your exploration, but we're also going to talk about it now. The number piece is your coefficient. That's what we call it. So if we go down to here, parts of numbers in scientific notation, your coefficient is a number greater than or equal to 1 and less than 10. So if we write it as an inequality, our coefficient is between 1 and 10, where it can be equal to 1, but it cannot be equal to 10. Our base is 10. So we go right here to base, it's always 10. Always 10. And then our exponent right there. Exponent is an integer, which means it can be positive or negative whole number, integer. So if we look at our two examples, we have our number, 2 million. In standard form, it's written with a 2 with 6 zeros after it. To write it in scientific notation, we're going to take the decimal point at the end of the number and move it over until we make a number that's between 1 and 10. If I move the decimal point over here, well, that becomes 200,000. That's not a number between 1 and 10. I move the decimal point there, that's 20,000, which is still not a number between 1 and 10. So we have to move the decimal point all the way over here until it is right after the 2, because then it's just the number 2, and that coefficient is between 1 and 10 times 10, always 10, and then our exponent, that's the number of times we had to move the decimal point. So if we count 1 movement, 2, 3, 4, 5, 6. We move the decimal point 6 times. It's these jumps. So count 1, 2, 3, 4, 5, 6. So our exponent is 6. So in scientific notation, that is 2 times 10 to the 6th power. For our second example, we have 5 thousandths, which means we have a decimal number in the thousandths place. So that is 0.005. Here, we're moving the decimal point until we get a number between 1 and 10. If I stop there, that's 0.5. That's a half. That is less than 1. So we have to go over until we're in front of the 5, and then we have a coefficient of 5. Then we count our jumps. 1, 2, 3. So when we multiply this times 10, we can't put to the power of 3 though, because that would mean we were making the number 5,000. We have to put it to the negative third, because that means 10 to the negative third, if you remember, negative exponents is going to equal 1 over 10 to the third. So that gives us that fraction, which would give us a decimal number right there, decimal number. So if you start with a decimal number, your answer is going to have a negative exponent. If you start with a positive number, or positive, I apologize, a non-decimal number, then your answer will have a positive exponent. Write in scientific notation. So let's get some more practice with this. Start with your decimal point at the end of the number. Move it until we have a number that's between 1 and 10. Can't stop there because that's 42, so I have to keep going. There we have a number that's between 5 and, I apologize, 1 and 10. Now for this one, we have to include all the numbers up to the string of zeros. It has to be 4.259. Then we count how many times we moved our decimal place to get our exponent. So 1, 2, 3, 4, 5, 6, 7 times. So 7 is our exponent. We have our decimal number. Start with that decimal point that is given, move it to the right until we get a number that is between 1 and 10. If I stop it right there, that gives me the number 5.74. That is between 1 and 10. If I kept moving it to the right, we would get 57.4, which would not be a number that's between 1 and 10. So we have to stop there. Times 10, now we need our exponent. Count the number of jumps, 1, 2, 3, 4, 5. Our exponent is -5 because we began with that decimal number. Write in standard form. Write in standard form. So we're taking this number, to 0.0075. Now, that tells us our coefficient. That tells us what we're starting with. Now, if we look at our 10 to the power of 6, that 6 tells us the number of jumps. If we think about how we take a number from standard form and write it into scientific notation, that exponent was the number of jumps that we took. So, we're going to take this decimal point and jump 6 times. 1, 2, 3, 4, 5, 6. Now if you notice, there are some empty spots. We are going to put zeros in those empty spots. So this number is 2,007,500. For our second example, we have our number that we're starting with, 1.685 times 10 to the -4. That tells us our number of jumps. The negative piece also tells us that we started with a decimal number, which means we're going to move our decimal point to the left. We're going to go over 1, 2, 3, 4. I have some empty holes that I need to fill. Fill those with zeros. So our number is 0.001685. Evaluate the expression. Write your answer in scientific notation. When we're multiplying with scientific notation, we have to multiply like things. So we have our two pieces, our coefficient piece and our power piece. So we're going to multiply coefficients together, and then we're going to multiply our powers together. So we are going to do 8.4 times 1.7. And it's going to be times 10 to the power of 2 times 10 to the power of 6. That'll give us our power. Do 8.4 times 1.7 and we get 14.28. Times 10 to the power of 2 times 10 to the power of 6. When we multiply powers, we add the exponents. We learned that in our last lesson. So 2 plus 6 would give us 10 to the 8th power. Now, with this, we have to be very careful, because if we look, is our coefficient a number between 1 and 10? No, it is not. So we have to move our decimal point over 1 so that it is now 1.428. But in moving our decimal point to the left 1, we have to up our power. That becomes 10 to the 9th power. By moving the decimal point to the left, we made our number bigger. We have to go up 1 more. Okay? Division works the same way. We divide like things, so divide your coefficient, divide your powers. 1.2 divided by 1.6 is 0.75 times 10 to the power of, we have to figure out that power. When we divide powers, we subtract our exponents. We also learned that in our last lesson. So 4 minus a negative 3 is 7, because remember, 4 minus a negative 3, that double negative becomes a positive, so it becomes 4 plus 3, which is 7. So our power is 7. Again, we have to look and see, is our coefficient a number between 1 and 10? It is not between 1 and 10, which means we need to move the decimal point to the right, 7.5 times 10. Well, in moving our decimal point to the right, we actually did make our number bigger. So instead of 0.75, that's 75 cents, we made it 7.5, which would be $7.50. So our exponent doesn't need to be as big because we made our number bigger. So we go down to 6. So I did misspeak in the other example. I apologize. Up here, when we moved our decimal point to the left, we made our number smaller, which means our exponent has to make up for that by going up 1, by going up to 9. You have to kind of make up that balance. So if you take a decimal place away, you have to lower your exponent. If you add a decimal place, then we're going up with our exponent. All right.